The partial pressure of nitrogen in the air is 600 millimeters mercury at 1 atm. What is the partial pressure of nitrogen in a bubble of air a scuba diver breathes when he is 50 feet below the surface of the water, where the pressure is 2.20 atm? So when you read the first sentence, we are given here two pressures, 600 millimeters mercury and 1 atm. 600 millimeters mercury is actually the partial pressure of nitrogen. So partial pressure of nitrogen is 600 millimeters mercury, and 1 atm is actually the total pressure. So P total is equal to 1 atm. And we know that 1 atm is also equal to 760 mmHg. So what can we get if we have the partial pressure of a gas and the total pressure? Well, we can get the mole fraction of nitrogen gas. So the mole fraction of a gas is equal to the partial pressure of that gas divided by the total pressure. So the mole fraction of nitrogen would be equal to 600 mmHg divided by 760 mmHg. So you make sure that the units would be consistent. So if your unit for partial pressure of nitrogen is mmHg, your total P total or the total pressure should be also in mmHg. So 600 divided by 760 is equal to 0.789. So mole fraction has no unit because the unit for pressures will cancel out. So the mole fraction of nitrogen is 0.789. So the question is asking for the partial pressure of nitrogen when the total pressure is 2.20 atm. So total pressure is 2.20 atm. So if we convert 2.20 atm into mmHg, we know that 1 atm is equal to 760 mmHg. ATM would cancel, and the total pressure is equal to 1672 mmHg. Then we would use the formula for mole fraction. So the mole fraction of N2, we know that it's 0.789. We are looking for the pressure of nitrogen, the partial pressure of nitrogen, divided by the total pressure, which is 1672 mmHg. So in order to solve for the partial pressure of nitrogen, that is just equal to 0.789 times 1672 mmHg. And that is equal to 1319 mmHg. And this is the answer to the question.